Let's see what happens. Worst case scenario, who knows? All right, Rip Admiral Akbar. 4.6, trapezoidal rule. So we're learning to approximate the area under the curve using trapezoids. We'll be successful when we can approximate the area under the curve with trapezoids. There's two rules in the 4.6 section. One for the trapezoidal rule, one for the Simpson's rule. Don't use either rule as it's stated in the book. Don't do that. You're just going to hurt yourself and you're going to feel bad. And I don't want you to do any of those things. They're more complicated than you need. And also, anytime you might need to use them on the AP test, you won't have access to a calculator in theory. So it's not really helpful to know them in the first place. So instead, we're just going to draw in trapezoids and find their area. And I have a Desmos activity we're going to start working on. I don't know if it's exactly what I want, but it's what I made, and we're going to play with it and see how well it goes. This is not as well crafted as the last one, but I think it's okay crafted. We'll find out. So we're just, again, drawing in trapezoids and finding their area. The area formula for the trapezoid. Now, the difference is that normally the area of a trapezoid is base 1 plus base 2 divided by 2 times the height. Instead of trapezoids looking like horizontally, like most of us think, we're going to think about them vertically. So the bases are going to be the values of the function at the different endpoints of the subintervals. And the height is going to be the distance between the x's, or the width of each rectangle, or width of each trapezoid, also known as the width of each subinterval. I'll show you that in just a hot sec. Another way to do that is do a left Riemann sum, do a right Riemann sum, and then average them on the interval. It's exactly the same thing. That's how I normally perform trapezoidal approximations. When I need to calculate it, I just do a left and a right and average them. That's literally what I did to get my check sum for this one. And that'll do. So I talked about how you draw in trapezoids like this. This height is base 1. This height is base 2. This distance is what I'm calling h. So then here's your area of a trapezoid. Base 1 plus base 2 divided by 2 times the height. Another way to think about trapezoids is you're just averaging you're like, well, that's almost a rectangle. Let's average the two heights to make a rectangle. It's literally the formula for trapezoids. Oh my gosh. That's how it works. That's it. But really. And by the way, the assignment's super short. There's 4 problems. In each of these that asks you to do a trapezoid approximation and then compare it to the exact answer, use your calculator to find the exact answer. Type in the definite integral, either in calculator or in Desmos, to get that. Now, here's what I would like to do in the meantime. I would like you all to go to student.desmos.com, log into the classroom, and find the newest activity, which is probably called 4.2-4.3 Riemann sum practice. And then go to slide 5. All right. It looks like several of you have made it there. Not everybody, but we're getting there. Let's see. Let me go to summary so I can find out who's there. All right, there's 2 of you who haven't got to the activity yet. So if you could get there, I can show you a couple things that I wanted to show you. So we looking for one more of you, and then go to slide 5. Don't start on slide 1 yet. I could just go to slide 5. Please go to student.desmos.com, log in with Google, and you should get to Desmos Classroom, and then we'll be on the most recent activity, which is called 4.2, 4.3 Reben Sum Practice. Fair enough. All right. Slide 5 is where we're going to start when we get a chance to get there. Oh, that's fun. I didn't realize he didn't get there last hour. Doesn't surprise me, but that's good to know. Cool. All right. So now that I've got you there, folks, so I'm hoping this all made sense. Maybe it doesn't. I don't know. We'll find out. So here's what I want to do. We're going to do trapezoid approximation of this function right here, f of x. So let's type this function in the space below. Dude. Hey, look, it graphs it right away. Oh my gosh. And then we're going to set up the calculator window so we can see the approximation of the area under the curve using a trapezoid approximation with 5 subintervals on the interval 1 to 5. So thinking about that real quick, that we have an interval that has a width of 4, and we're going to put 5 equal subintervals in there. So 4 divided by 5 should be 0.8. So that's something to keep in mind later. But let's put our left bound and right bound in here. So my left bound is 1, my right bound is 5. I'm going to put 5 of them in here, and that might help you. But also it looks, I don't know, if your window should be exactly like mine right now, and that looks pretty small, and I can't draw on it yet. In order to draw on it, you need to put in some values here. I'm going to go 0, 5.5, and let's go -1 so I can see things, and I think 10. Oh, I don't even need 10 on this one. Which one was I thinking I need 10 for? Oh, it wasn't this. 6. Let's put a 6 in there. So this is showing me a bunch of left endpoint rectangles for this interval. I don't really want left endpoint, but it will help me fill out this column real quick. So I know that I'm starting at 1. And remember, I said that we have an interval of 4 with 5 equal intervals. So let's go up by 0.8. 1.8. If I can find my numbers. Let's go over there. 2.6, 3.4, 4.2. Again, I'm getting these other endpoints just by adding 0.8 to my initial endpoint, which was right here at 1. For the right endpoints, well, I'm not starting at 1. My right endpoint is going to be 1.8, then 2.6, 3.4, 4.2, and I'm going to end at 5. Now, it's going to say your values are incorrect, even if you type this in, because when I initially coded it, I had it referencing the wrong table. So at least I know that. I'm going to finish fixing the activity, and I'll make a copy and assign it as extra practice to go through and to try these things, just to see that it all should work for you. And by the way, when you enter the right endpoints, look, it threw little dots where you think those values should be. So the right endpoints you can check to see if it makes sense. So here's what I'm gonna do is I'm gonna take off the number of subintervals now because I don't really want that messing with the next thing I'm gonna do. You don't have to take them off, but I'm going to. So then let's go to slide 6. Because what I'm going to do is I'm going to show you a little bit, and then I'm going to let you try to finish it up. All righty? So I'm going to sketch these, and then I'm going to try to write out the expanded sum and then calculate it. Well, to draw in the trapezoids, let's draw in some heights. So at x sub 1 is one height. There's another one here at x sub 2. And there. And there. And there. And there. I'm just going to take a different color so that it shows up a little bit better. And to finish making my trapezoids, I'm just going to connect them. Boom. Now I can see each of my trapezoids. I have 1, 2, 3, 4, 5 trapezoids. Alrighty. So to start working on the expanded sum is just how would you write this out before you start calculating it? Well, if you look at this first trapezoid, it's going to be f of 1, which I'll figure out later, plus f of 1.8 divided by 2 times 0.8, which is the width here, right? 1 to 1.8. The width of this is 0.8. So that's where this came from. Again, this part right here, that's my width. This was base 1 for this first trapezoid, and this was base 2 for the second trapezoid, or for the first trapezoid. But that's only one of them. There's 5 of these. So I could do plus another fraction, f of 1.8 plus f of 2.6 over 2, because I'm averaging them, times 0.8. And this second one is for this second trapezoid. Because in this case, f of 1.8 is base 1, f of 2.6 is base 2. Add them together, divide by 2, multiply by 0.08 or 0.8. So here's what I'd like you to finish doing is I'd like you to finish writing out the expanded sum, and then I would like you to calculate what this is. Make sure to round everything you do to 3 decimal places. And when you do that, once you write out all 5 of the pieces of this expanded sum, find each and round each one to 3 decimal places, then add all 5 of them up and put that number here. All righty. And if you do that correctly, it should give you the correct answer. So I'm going to give you the next 7-8 minutes to work on that. Okay, go. Resuming recording real quick. Something I need to point out. Most of the time on graphs, when we do Riemann sums or trapezoidal approximations, we make all the subintervals equivalent. they don't have to always be the same. And in calculus, we start seeing that a little bit more, especially if you work with tables of values. And that's usually what the AP test likes to do with these, give you a table of values and have you do approximate left and right Riemann sums with them. That's what they really like. So that's something I need to point out to you. They don't have to have equal intervals. The only reason we did in pre-calc was to develop the integral notation, the definite integral notation. Yeah, that's it. I think that's all I have for you today, folks. I'm sure I could keep going, but I'm going to stop with there. Yeah, I'm going to stop there. Have a great day, folks. We'll talk to you later. Oh my gosh, next class is starting. Bye.